Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is count total set bits, and it is a medium level problem. So before starting with the video, I just wanted to say that if after watching this video you feel that this video was helpful for you, then do consider dropping a like on this video, because it really helps the YouTube algorithm to actually understand that this video was helpful for you, and it will be able to recommend these types of videos to more people like you. And don't forget to share your thoughts in the comments. Tell us what did you feel about today's problem, and engagement like this on this particular video will really help it to reach more people. So that's it, and let us quickly start with the problem statement. So they say that we have been given a number n and we have to find the total number of set bits in the numbers from 1 to n, right? So let me just discuss this particular problem. So for example, if we consider the number let's say 4, right? So number 1 is represented as 0 0 1, 2 will be represented as 0 1 0, 3 will be represented as 0 1 1, and 4 will be represented as 1 0 0, right? So you see one set bit is here, 2, 3, 4 and 5. So there are a total number of 5 set bits from 1 to 4, right? Now let me just try writing all the numbers in binary from 0 0 0, right? So actually what is happening in this particular question is, since the value of n is up to 10 to the power 6, what you can do is you can just quickly iterate through all the values, and for each of the values you can count the number of set bits. So counting set bits is not very difficult. So even if you consider the worst case, it will be 10 to the power 6 into 32, right? So this value will obviously be less than 32 because we need 32 bits for 10 to the power 9. But since 10 to the power 6 is smaller than 10 to the power 9, you will need even less number of bits for this particular value of 10 to the power 6. So why am I saying 32? What you can do is, for each of the numbers in the range from 1 to n, you have some bits like this. You can go individually on each bit and check whether that particular bit is set or not, right? So this will be the brute force approach, and it will take this much time, O of 10 to the power 6 into 32, right? This approach will also work, and I believe, I don't know, I didn't try submitting on it on GFG, but I believe that this will certainly pass the test cases because it is well within the time limit, right? But according to the question, they say that they expect a O of 1 time complexity. So we are trying to discuss how we can solve it in O of 1. So if I try to write all the numbers in binary like this: 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1, and let me just write a few more: 0 1 1 0 0 1 1 1, right? So I've written numbers from 0 to 7. So I can always include 0 because it will not contribute any set bits. It is just to make sure that the pattern is complete, right? So this is 4, this is 5, this is 6, and this is 7. Now you must have observed this particular pattern, that for this particular bit 1 is repeating after every 2 digits, right? So for every pair, for example, here we have gone up to 8 numbers, right? So it's from 0 to 7. We have considered 8 numbers in total. So after every 2, 1 is repeating. So we will divide it by 2 and the total answer will be 4, right? So at the 0th position, there will be 4 bits contributing, right? If we take the numbers from 0 to 7. So let us just erase this particular part and write it somewhere that for the 0th bit, 4 bits are contributing, right? There are 4 set bits. Now if we try to consider at position 1, you see that after every 4 numbers, this answer is repeating, right? After every 4 numbers, there is a contribution of 2 bits. So from 8, we will divide it by 4, and this will be 2. Since at each group is contributing 2 bits, so we will multiply it by 2, right? And at the 1th bit, the total contribution will be 4. Again, what we'll do is we will remove this part and let us see at the second bit, right? At this particular bit, what is happening is it is continuing in a group of 8, right? And after every group of 8, we see that each group is contributing like 4 bits. So what we'll do is we'll divide this particular value by 8, and we will see that this is one group. Each group is contributing 4 values. From the second or the second index or the second bits, we will be receiving a contribution of 4. So at the end, what we can do is we can add all of these values. Now you might consider a case where you see, let me just erase this first. So you might consider a case where we only have numbers till 5, right? So what you will do in that particular case? So since we have numbers till 5, that means we have taken 6 numbers from 0 to 5. Now if we try to find for the second bit, you will see that we will try to divide 6 by 8 and it will show us that we have 0 complete groups, right? But there might be a case where we have a half of somewhat of that group, and in this particular half group there are some values that are contributing to our answer. So what we will do is we will find the value of 6 mod 8, right? When we find 6 mod 8, in this particular case it is coming out to be 6 only, but there might also be a case where we have let's say some value 8 plus 6, and that will be equals to 14, right? So this particular 14 value will contribute one complete group and the other group will be half, right? So that is why we have to find 6 mod 8. Now once we have found 6 mod 8, we see that there are a total of 6 values. We know that if there was a group of size 8, so this was group of size 8, the first 4 values were 0, right? And only the rest 4 values were contributing. So what we can do is we can do 6 minus 4 and this will be equal to 2. So you see that there are only 2 bits contributing here, and these are those 2 bits, right? So this was the whole idea of the problem. So what you have to do is for each of the bits from 0 to like this 0 to 3 from 231, what you have to do is you will have to find a pattern, the size of the pattern. So for the 0th bit, the pattern is of size 2. For the 1th bit, this pattern is of size 4. Then again 8, and this keeps on increasing. Now once you have found the pattern, you have to find the number of complete patterns. So how do you find the number of complete patterns? For example, if you were trying to find the number from 1 to 7, so just add 1 to it. 7 plus 1, that is equals to 8. Why am I adding 1? To consider the 0, so that it completes the pattern and we have no differences, right? And again 0 will not be contributing anything, so this will not change our answer, right? So the only reason I'm including 0 is to complete the whole pattern. So that is why I'm taking 8 now, right? So since this particular group is of size 2, I can easily find out the number of groups by doing 8 by 2. Now if I found the number of groups, I can easily find the number of set bits contributed by that groups, because I know if the size of the group is 2, only 1 bit will be contributing to the set bits. If the size of the group is 4, only 2 bits will be contributing to the set bits, right? So this way I can find the total number of set bits by multiplying the number of contribution in each group and the number of groups, right? Now if there is some value that is forming a partial group, right, like we discussed in this particular case, so what we'll do is we will take our current value of n and find its modulo with the group size. So let me just write it g size, right? Once we have find its value, then we will subtract g size by 2 from it, right? Because you know, if there is a group of size 2, only the last 2 bits or only the last 2 numbers will be contributing some set bits to our answer. So the first 2 bits will not be contributing anything. That is why we subtract g size by 2 from this particular value. So if we subtract this particular value, this will remove the starting bits which were not set, and we will only have the number of bits which were already set, right? So once we do this for all the bits from 0 to 31, we will be able to find our answer. Now again, this particular part, the second part, where you try to find the number of bits in a partial group, it is not necessary to do for the 31st position. Why? Because at 31st position, you know that you will always be able to find the complete groups and there will be no partial groups, right? Because there will be only one group of a total size of 2 raised to the power 32, right? There can be no other group than this, right? So let us discuss how I implemented it in the code. So what I'm doing is I'm creating a variable answer, initializing it with 0, and I'm incrementing the value of n by 1 because I also want to include 0. So now for each of the bits from 0 to 32, what I'll do is I'll try to find the value of n by group size. So the group size will be, for the 0th bit, the group size will be 2 raised to the power 1. Similarly, for the, let's say for the xth bit, the group size will be 2 raised to the power x plus 1, right? So you must have observed this particular thing in the examples. So since for the 0th group, the group size is 2 raised to the power 1. For the first bit, the group size is 2 raised to the power 2, that is 4, right? So this is what we are doing. So we find the group size by 1 left shift I plus 1. So this will calculate 2 raised to the power I plus 1. So I divide n by this particular value. Now since each group will be contributing half of its value, half of the value of the group size, I am doing 1 left shift I only. Here I was doing I plus 1, here I am doing I only, right? So I multiplied the number of groups with the set bits contributed by each group. So I just add this value to my answer. Now only if the value of I is less than 31, I find the value of y. So this y will store the number of remaining bits, right, which are not counted yet in complete groups. So I calculate, again, this is the group size. I just take the modulo of n with the group size. Now I subtract half of the group size. Why half of the group size? Because if the group size is 8, the first 4 values will be 0, right? So I just subtract it from the value of y, and if the value of y becomes negative, that means I have to take the maximum with 0. So when will it become negative? It will become negative when the value of n is among the first half of the group, right? So in that particular case, the value of y will become negative or equal to 0. If it is in the second half, then the value of y will be a positive integer. So I just subtract this value from y, I just take it maximum with 0, right? So at the end, I can just add y to my answer. So after I have computed this particular thing for all the bits, I can just return my answer. So this was all about today's problem of the day, count total set bits. Now you could have also done it in like brute force manner. I believe that would have also passed the test cases. But still, this was the most efficient approach we can solve this question with. So let me just quickly submit this problem and show it to you that this passes all the test cases. So we see that this is passing all the test cases, and I hope that this video was helpful for you. And if you guys were really able to understand the solution, then consider dropping a like on this video, and don't forget to subscribe to the channel. I see a lot of people who watch these videos have not subscribed yet. So definitely consider subscribing to the channel and share the channel with your friends so that the next video drops. Keep coding, stay safe, bye bye.